2018, question 4 for AB Calculus. All right, I'm just going to start with reading part A. Use the data in the table to estimate h prime of 6. I'm going to start there, but I want to remind myself that there is more. So I'm highlighting what I'm doing, coming back to the end of the highlight. H prime of 6 is approximately. The times 6 is in between 5 and 7, so you're going to do a slope formula on those two data points. It is best if you explain that you are using the h value of 7 minus the h value at 5 over 7 minus 5, and then put the numbers in of 11 minus 6 over 7 minus 5 gives me 2. You can leave it that way or take the risk, subtract, and cross your fingers. All right. It then goes on and says, using correct units, interpret the meaning of h prime of 6 in the context of the problem. So you want to explain this as if you were talking to someone who knows nothing about calculus. If h represents the height of the tree in meters, and t is representing time in years, h prime of 6 is telling me how quickly the height changes with respect to time in years. So then how do you put that into words? I'm just going to grab the answer and just show you the words that they used, but know that it's your job to think, what is that in kind of layman's terms? So it is the rate at which the height of the tree is changing. You've got to say the units in meters per year at time t equals 6 years. All right. Part B. Explain why there must be at least one time. Oh, right there. This is either intermediate or mean value theorem. Explain why there must be at least one time between 2 and 10 such that h prime of 2 is equal to 2. The fact that I'm given values of h and I want to show that h prime is equal to something, this looks like mean value theorem. For mean value theorem, you need to state, I am using mean value theorem. You need to write the hypotheses. The hypotheses are that the function that you're saying has a particular answer to its derivative. That function is continuous over the closed interval, (2 to 10), and it is differentiable over the open interval 2 to 10. And what you're going to start with is looking at the slope through the endpoints. If the slope through the endpoints gives you 2, ding, ding, you just won. If it doesn't give you 2, then you're going to have to look at other data points within this time frame to figure out who is going to give you an average slope of 2. Because it's with the value theorems, if you can show that it works for a sub-interval of the main interval, then it works on the main interval. So I'm going to write h of 10 minus h of 2 over 10 minus 2 is equal to 15 minus 1.5 over 8. And then if you take a moment to think about it, that's not 2. This is slightly cruel. You now have to scour through your data points and figure out what pair of numbers is going to produce a slope of 2. You might find it right away, you might not. Looking at the answers, I can tell you that it occurs between 3 and 5, but that's slightly cheating because I'm looking at that, but that's so just I save time on the video and I save your time instead of me sitting here going one at a time through everything. So h of 5 minus h of 3 is 6 minus 2 over 5 minus 3. So now what you're able to do is say that the mean value theorem guarantees at least one time over the time frame 3 to 5. And I'm going to say at least one time, comma, c over 3 to 5. H prime of c must be equal to 2. And I've already written all the information that guarantees it. However, you should state that the interval of 3 to 5 is a subinterval of the time frame they gave you of 2 to 10. And therefore, there must be a c between 2 and 10 if it's in a subinterval, for which it is true. Let me put the answers up so you can see how the problem was written. And then I'm going to move on to part C. So that's how they wrote the answer. Part C wants you to use a trapezoidal sum with 4 subintervals. And this is asking you to approximate the average height of the tree. Very important, very important. You are going to use a trapezoidal sum, but you first want to write the expression of what it is they want you to approximate. The average height of the tree is going to be found by integrating the height of the tree over the time interval and then dividing by the length of that time interval. And I want to remind you that when you're doing average value in this manner, the units you have for the integrand h of t are meters in this case. You're going to multiply by the time units. You'll have meters times years, but then you're going to divide by the time unit to go back to just meters. So know that when you do average value, the units of that are always the same as the units of the integrand. So you're going to write this integral and then say that this is approximately. Now, the trapezoidal approximation will only be for the integral itself. You need to write a 1/8 in front and then do the trapezoidal rule after that. With the trapezoidal approximation, you should remember that we are using the area formula of base 1 plus base 2 over 2 times the height. The height is all of the change in times, which the change in times are 1, 2, 2, and 3. Those are going to be the h's. The bases are the actual height values. And the base values. So when the height is this 1, the two base values are 1.5 and 2. Then you're going to add that to the area formula for which the height is 2 and use the bases 2 and 6 for that. And then I'm going to put the answers up instead of tediously going through one area formula at a time. Since you do not have a calculator on this problem, I would advise not getting to this point. You can leave it as this big giant expression. And let's make sure that we have answered the entire problem. It said to use the data to approximate the average height. So there it is. All right, moving on to part D. The height of the tree in meters can also be found modeled by the function g. So here is a moment where they give you a table of values problem, and later on they give you a model that is an equation that you're going to use instead of the table or with the table. In this case, you're going to use it instead of the table. All right, so g is also the height of the tree. X is the diameter of the base of the tree, and that's what it is in terms of. It says when the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. The diameter was given as variable x, so they just told you that dx dt is positive 0.03, and I want to point out that it's positive because it's increasing. Then it goes on and says, according to this model, what is the rate of change of the height of the tree with respect to time? Now, g of x is representing the height of the tree. I want to know this rate of change with respect to time. I ultimately want to know dg dt, but g is given in terms of x. Now, what I would do is I would take the expression for g of x that is given in terms of x, and I would say that I need to take the derivative of this expression, but I need to do it with respect to time, not with respect to x. So as I go through the derivative, I start with quotient rule. With the quotient rule, I have low d high. Now d high is you have a constant multiple of 100, and then the derivative of x with respect to t. That was low d high minus high d low. For d low, you're looking at taking the derivative of 1 plus x with respect to time. The 1 alone is 0, but the x is dx dt. Square the bottom and away we go. If you look at the result of how the AP test wrote this, they wrote that, your g prime of t is the derivative of g with respect to x multiplied by dx dt. And realize that this is the chain rule. This is basically saying that g has a function inside of it that is x with respect to t. When I take the derivative with the chain rule, I take the derivative of the mommy function, I take the baby function, and I give mommy her baby, and then I multiply by the derivative of that baby, x, with respect to time. And know that that is exactly the same thing as I have here, because dx dt could be factored out of this subtraction sign to be a separate g prime of x times dx dt. From here, it's a matter of plug and chug the information. I just went to the wrong problem, I think. There we go. Plug and chug the information. And let's see, according to this model, meters per year. At the time, hold on, got to read the whole thing. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So at the time when the tree is 50 meters tall, you are going to need to realize that's saying that G is equal to 20. You're going to have to take the function G of X, set it equal to 20, and solve that equation just to know what the X is that you're going to plug in to each of these X's. You already have dx dt, 0.03. Once we find X, it's just a matter of plugging them all in, and you've got an answer. So I'm going to multiply both sides by 1 plus X, distribute my multiplication over my addition, subtract 20x, and then divide by 80. And that will reduce to 1/4, as long as I didn't mess up my arithmetic. So let me grab the answers to make sure that I have, wait a minute, I think I did something wrong. I tried to go about this too quickly, because I'm seeing that they got x equals 1. So, oh my goodness. That's because I just wrote the wrong number. It said when the tree is 50 meters tall. I don't know where 20 came from. You've probably been yelling at me on the screen for quite a while that it's 50, not 20. That means I have 50 is equal to subtract 50x, divide by 50, and I have x equals 1. And now I will plug 1's into x's, and the rate that was given. And here is the answer. Voila.